We are continuing our discussion of JFET with a look at three of the common configurations used in JFET amplifiers. The JFET equivalent of bipolar transistor amplifier configurations are common source, and this would compare to the common emitter in bipolar, the common gate, that would compare to the common base, and then the common drain, which would compare to the common collector in the bipolar. First, we're going to look at the common source amplifier, and again this compares to the common emitter amp. We'll note the CS bypass cap grounds the source for AC, hence the common source. Remember, the reason we called the common emitter amp, the reason we gave it that name, was because there was a capacitor tied directly to the emitter that went to ground. This was a ground for purposes of AC, and so this is instead of common emitter, we're calling it common source, and so that is why. We have C1 and CO that operate as coupling capacitors. C1 here couples the signal source to the gate, and CO couples the output to the load. And you'll notice the load here, there's a reference of 0 volts right here. At this point, it might be of note that, and we talked about this in common emitter, that the drain is at a DC level. If we had, let's pretend we had 10 volts positive here, to make for maximum signal flow, this would be designed, so this would probably be about 5 volts. And so the output that's developed here, the AC, it's going to be AC, but it is going to be at a 5 volt level. And if you were to look at an oscilloscope, you would see 5 volts here, but at that 5 volt level you would see this AC signal riding there. Now, the reason that you have this output capacitor here, this coupling capacitor here, is that you do not want that DC on the load. So this, remember that a capacitor does not pass DC, only AC, so the AC signal is passed across the cap and it goes to the load, and notice the reference here at 0 volts. The phase inversion is 180 degrees from input and output. This is no surprise, this is what we had with the common emitter amplifier as well. This provides high voltage gain, or high voltage and power gain, and it tends to be a little bit unstable in terms of current gain. Oftentimes they will place a component, another resistor in here that tends to swamp out those variations in current gain. That's also done with the common emitter amp. And we continue here. Look, this is still the common source amp. A few things that we need to mention. The gate of the JFET returns to ground through RG. So remember, we have the signal source here. Notice the Rint here. That represents the internal impedance of the signal source. Remember, we talked about output impedance and how that when you generate a signal, part of that signal is actually dropped across the source. And so in this case, 500 ohms is how much of that signal will be dropped across the source. Notice the path. It goes from here through C1, and then there's a large 1 megohm resistor right here. Now, there are a couple ways that AC signal can go. It can go here. It can also go here. But recall that the gate source junction does not pass current. It is a electrostatic difference that establishes the biasing for the drain, and it establishes a depletion layer. So the current flow is going to be through this leg right here. And recall, notice the large 1 megohm resistance right here, and the small output impedance of the signal source. So most of that signal will be felt right here and delivered directly to the gate. As current flows through RS, it places a positive voltage on the gate. This reverse biases the gate source junction required for operation. Okay, we're talking about this point right here. Recall that current is going to flow from the ground to the drain, and in that process current will be dropped across RS and RD. This will cause a voltage drop here, and since this is, we'll just pretend this is a positive 10 volts, this will be a positive voltage right here. The gate has no DC biasing, so it will be 0 volts, and so in respect from gate to source, this positive voltage will act as the negative biasing required for the gate source junction. The gate has no loading effect since RG provides the ground. We talked about that already. As the input varies, output changes across RD. So as we have an input that is varying, our output will vary across the drain, just like we did with a common emitter amplifier. The common gate, your text doesn't say much about this. It just shows it as a amplifier that parallels what we looked at is in the common base amplifier. Remember, we had the base grounded and we injected a signal into the emitter. Well, this is the same kind of configuration, only we're injecting a signal into the source and we're having the gate grounded rather than the base. Our final amp we're going to look at is the common drain. Notice the for purposes of AC going up to VDD, that looks like it's connected to, and that looks like ground for purposes of AC. This is also referred to as the source follower, and recall that we looked at the emitter follower in bipolar. We have our signal source coming in, it goes to the gate, and then it goes to the source. Now again, in this configuration, much like the emitter follower, there was no gain here. The thing that we got from this circuit was that it dropped the output impedance down very low so that we could couple most of our signal to, and here we have a load right here. This provides for excellent coupling so that most of the signal is not lost on the amp but is delivered directly to the load. And this type of amp is very popular with high power amplifiers. Okay, summary of JFET characteristics. The source and drain terminals connect to the ends of the channel material in a JFET, and recall that the source and the drain in most JFETs are interchangeable. The gate source junctions are reverse biased in a JFET. Increased reverse bias in a JFET causes the channel resistance to increase. So the more reverse bias, the more resistance it will have in the JFET channel. A JFET has maximum source drain current with no bias. So with 0 volts across a JFET, you have maximum current. This is directly the opposite of what you see in common emitter. A JFET can be used in digital circuits by using saturation or cutoff modes. Common source, gate, and drain configurations are comparable to bipolar amplifier configurations. Common source amps have 180-degree phase inversion. Common source amps have very high input impedance. Normal operation is such that current flows from source to drain. And this concludes section 10-2.